I'm Jenna Jarab, I'm 16, and I wanted to know what determines the melting and boiling point of a substance.
I'm Rodney Schreiner. I'm a scientist in the chemistry department at the University of Wisconsin-Madison. Before we can answer that question, we need to know first, what is a solid, what's a liquid, what's a gas. These three materials behave in terms of the tiny particles that they're made up of. All of them are made up of molecules. In a liquid, the particles don't stick together as strongly as they do in a solid. They can move past each other. And that is what allows me to pour a liquid from one container to another, because the particles don't stick to each other. They will move from one to another very easily. In a gas, the molecules are moving around constantly and they are not in contact with each other, but if they are, only briefly. And the only way I can think of to show you that is to shake this bottle and get these beads that represent molecules moving around. Now, this is where the question of temperature comes in, because I've shown you molecules of gas moving and told you that they move, but in fact, molecules in liquid also move. The molecules in the solid also move. They are actually vibrating, not moving very far, but they vibrate constantly. And what the temperature represents is the speed at which the molecules are moving. The higher the temperature, the faster the molecules move, or the faster they vibrate. Now, in a solid, as the molecules vibrate more and more and more strongly, then they can move past each other. And at some temperature, they will have enough speed, enough energy to move around past each other. And when they can move around past each other, they become a liquid. So the melting point is the temperature at which the molecules in a solid can move past each other and form a liquid. As the liquid molecules are moving around, at the surface of the liquid, some of the molecules are actually getting out of the liquid. They escape from the liquid, but they don't get very far because there's air at the top, and the molecules of air push the molecules of liquid back down into it. So the air is pushing down on the surface of the liquid, but as you raise the temperature of the liquid, the molecules move faster and faster, and more of them escape. And eventually, the molecules at a particular temperature will push the air away at the same force that the air is pushing down. That's the boiling point, that temperature at which the gas from the liquid is pushing the air with the same force that the air is pushing back.